Welcome all of you. I am Vishwas Khare from SSR College Silvassa. In this tutorial, we will talk about examples of vector space. Example: let V is equal to M 2 cross 2 is a collection of all matrices A, which is A11, A12, A21, A22, where A11, A12, A21, A22 are real numbers. That is, V is a set of all matrices of order 2 cross 2 on R. If A is equal to A11, A12, A21, A22 and B is a matrix B11, B12, B21, B22 in R and alpha belongs to R, we define A plus B is equal to A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22, that is usual addition of matrices, and alpha dot A is equal to alpha A11, alpha A12, alpha A21, alpha A22. Show that V is a vector space. Again, to show this, we'll show all the 10 properties of vector space are satisfied. First, for A is equal to A11, A12, A21, A22 and B is equal to B11, B12, B21 and B22 in V, we have A plus B is equal to A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22. That is a 2 cross 2 real matrix, so it belongs to V. Secondly, clearly for all matrices A, B, C belongs to V, we have A plus B plus C is equal to A plus B plus C. Because we know the matrix addition follows associative law. Hence, associative law holds. Third, there exists a zero vector, that is zero matrix, which is 0, 0, 0, 0 belongs to V, such that if we add A plus 0, we'll get 0 plus A, which is equal to A, for all A belongs to V. Here, this 0, 0, 0, 0, 0 is a zero vector in V. Note that here, in this vector space, zero vector is a 0, 0, 0, 0 matrix. Fourth, for each A11, A12, A21, A22 matrix, there exists minus a matrix minus A11, minus A12, minus A21, minus A22, such that A plus minus A, which is equal to 0 matrix, which is same as minus A plus A, 0 matrix. Hence, inverse of each element exists in V. Fifth, clearly for all AB belongs to B, we have A plus B is same as B plus A, because we know that matrix addition follows commutative law. Hence, commutative law holds here. Sixth, for all A belongs to B and alpha belongs to R, we have alpha dot A is equal to alpha A11, alpha A12, alpha 21, alpha 22, which is again a 2 by 2 real matrix, so it belongs to V. 6. For AB belongs to B and alpha belongs to R, we have alpha dot A plus B is same as alpha dot sum of A plus B first, so A11 plus B11, A12 plus B12, A21 plus B21, A22 plus B22, which is same as alpha in bracket A11 plus B11, alpha A12, B12 and so on, which is same as alpha A11, alpha A12, alpha 21, A21, alpha 222 plus alpha B11 plus alpha B12, alpha 2 B21, alpha B22, which is same as alpha dot A plus alpha dot B. So we got alpha dot A plus B is same as alpha dot A plus alpha dot B. Next property, for all A belongs to B and alpha beta belongs to R, we have alpha plus beta dot A, which is same as alpha plus beta A11, A12, A21, A22, which is same as alpha plus beta A11 and so on, which can be written as alpha A11, alpha A12 and so on, plus beta B11, beta B12 and so on, which is same as alpha dot A plus beta dot A. So we finally got alpha plus beta dot A is alpha dot A plus beta dot A. So this property also satisfies. Ninth, for all A belongs to V and alpha beta belongs to R, we have alpha beta dot A is alpha beta A11, A12, A21, A22, which is same as alpha beta A11, alpha beta A12, and so on, which can be written as, because alpha is a real number, beta is a real number, A11 is a real number, so it can be written as alpha in bracket beta A11, and this as so on. We can write same way. So which is equal to alpha dot beta A. As this property, hence we got alpha beta dot A is alpha dot beta A. So this property also satisfied. Then there exists 1 belongs to R such that 1 into A is 1 dot A11, A12, A21, A22 is equal to A for all A belongs to B. Hence this property also satisfies. As all properties of vector space are satisfied, hence V is a vector space.